now while we're working. So in any case, you have this worksheet in front of you, and we're going to talk about linear growth versus exponential growth. So Fred said my colt grew, so one and the same age of friends by a colt. That's a baby horse, right?
It's a donkey.
Donkey. No, it's not a donkey. Both colts have a weight of 50 kilograms. After 1 month, they compare the weights. Fred said my colt grew 10 kilograms. Andy answers my colt grew 20%. After another month, they meet again and compare the weights. Fred said mine grew another 10 grams. Andy said mine grew another 20%. Suppose that the growth pattern continues for the number of months. Complete the table showing the growth for the first 8 months. Okay, so we're going to try to at least do the first month. So after 0 months, what's the weight of Fred's colt?
0.
No,
it's 50.
It doesn't. Right, it starts at 50, right?
Oh yeah.
So 50, and they're both 50, right? After 1 month, Fred's. What's Fred's? What's Fred's? It's 60, right? After 1 month, how much does Andy's colt weigh?
60.
How did you get that, Chase?
Because you move the decimal place over once to the left to get 10%.
Right, so it's going to, okay, so it
60.
postponed for 4 hours. Okay.
No, restart now.
So 50 plus, how do I take 20% of 50? Well, now you multiply 50 by that, which does make 10, right? Which gives you how much? 60, just like Chase said. Right? You guys understand that? Yes? Okay. So now, the next month, how much does Fred's colt weigh? 70. How much does Andy's colt weigh if it's going up 20%? 60 plus what? 0.20 times what? Times 60, right? Because you're multiplying the new number. So what is that? What's 0.20 times 60? No. 12, right? So this is 60 plus 12, which is 72. Good. So let's do one more, then I'll let you guys do the rest with your calculators. How much does Fred's colt weigh on the third day? 80. How much does Andy's colt weigh? 72 plus what? 0.2 times what? Excuse me, I'm teaching a lesson. Just hold on, I'll be right with you. Okay. 0.2 times what? 72, which is equal to what? 14.4. So I'm going to take 72 plus 14.4, and I get what? 86.4. Okay? So you guys go through, you probably need to use a calculator and complete that table. Go ahead. Okay. I'm going to pause here. I'm going to go. And let me unpause. What goes down this way? What goes down this column?
90.
90, then what?
100.
100, then 110. Okay, 120. That's easy enough, right? That's called the linear function because it goes up linearly. Who could tell me what comes after 86.4? What came next, Mandy?
103.68.
Yep, they got like 103.7 about there. Is that about what you got?
Yeah.
What do you get for the next one?
124.4.
120. They got 124.4. Any questions about that? Okay. What do you get for the next one, Jake?
149.3.
You did. You did get 149.3. Very good. What do you get for the next one? Quinn, what do you get for the next one?
179.
Very good. They got 0.2. Close enough. 179.2. What do you get for the last one, Will Ponder?
I got 209.15.
209. Is that what they got? 209 point. That's not what they got. What do you get, Kaylee?
I got 214.
Yeah, they got about 215, somewhere about there, right? Did you guys get all that? Okay. So now, what I could do with all that information, okay, I could take that info and I could graph it, okay? The way the vote goes could be using greater plots you found in the table, graph Fred's code on the dotted line and Andy's code on the solid line. So I think that you guys can do that. Thank you. Okay? So we're gonna take this chart and partial. So the first one, we're just gonna plot some of these points. Let's see if I could go back and copy this table. Let's see how clever I can be. Partial. Here we go. I want to copy that. Edit, copy. And then I'm going to go to the next page. Do that next page, and I'm going to go edit, paste. There it is. So now I have the table right there. Okay. So now I could take this information and I could make a graph of it. Okay. So 50. So this is 0 comp. So we're going to graph. It looks like they both start. We're going to start this graph at 50. So it's 0, 50, and then 160, and you guys could graph the points. Go ahead and you do it. Okay, let's see what kind of graph
Just a dot.
you guys. Yeah, just the dots. Okay. So go ahead and give that a shot while I'm going to freeze it and I'm going to do my
So are we doing two lines?
two different graphs, right?
Mr. Leader, how far does it go in between?
How many bars is
Yeah.
60 of?
60.
It's exactly on the 60.
Yeah, just kind of try to line it up. It's even with the 60, right? So it's kind of a squished graph, but so 260, 370.
Which one are we?
Both of them, okay? So you're gonna graph both of them. So 0, 60. Yeah, not so bad. So you want to plot the point 272, right? For the second graph. Okay? Wait, one should be 60, right?
Yes.
Oh, I messed up. I'm talking to myself. So I'm going to unfreeze. I'm going to unfreeze, and I'm going to unpause. Okay. Uh-oh. My Mobi freeze. Oh, there we go. I made lots of empty dots. So if you did it, did you guys, how about those dots get there? Go away, dots. Let's get my video. Oh, it's still working. So do you guys get something that looks like this?
Yep.
Maybe? Okay. So this is obviously this one, the red one. I'm going to try to sketch in there. So the red one kind of starts at 50, but he kind of goes up, and he keeps going up kind of like this, okay? And the other guy, he, what's the other guy's name? Fred, okay? Fred starts here. He's going to be green. He's going to be a solid line. He's going to have an arrow on one end, and he's going to go up like this through these points, okay? Did you guys all get something that kind of looked like that? Okay. What is the most striking difference between the graphs? Who could tell me what the most striking difference is between the two graphs? Yes, Ian.
Andy's is curved and Fred's is straight.
Andy is curved and Fred's is straight. Who could tell me another difference? Very good, Ian. What's another difference? Yes, Kate.
Fred isn't going up at a constant rate.
Ah, very good. Fred's isn't going up at a constant rate. And as time goes on, whose colt is gonna weigh more? Fred's, right? Do you think any of these growth patterns is realistic for a longer time period? Why or why not? What do you think? What do you think? Why not, Cole? You said no. Oh. Who could tell me why this isn't realistic? Yes, Will Ponder.
Of course. It's not going to grow like that forever.
Very good, right? Otherwise it would go up infinitely forever, right? At some point, it's going to stop growing, right? So at some point in reality, right, it's gonna stop growing, and it's just going to kind of level off, you know? So it's kind of going to go up for a while, and same with this, right? It's going to hit a plateau and then eventually level up, okay? So, yeah, it can't grow forever. Very good. Okay, so moving on, let's see what's next. What do we got here, okay? Write the function that describes the relationship, okay? So you should be able to do this because this is changing by how much each time? 10, okay? So this is called a linear function, and it's y equals mx plus b. Where did this graph start? Where did this graph start? Will you please put your phone away, Will? Okay. What's b in this case? 50, right? So y equals something x plus 50. Who can tell me what goes here? What goes there? 10. That's it. Okay? Y equals 10x plus 50. Sometimes it's kind of nicer to write this, even though it's not y equals mx plus b form, y equals 50 plus 10 times x, okay? Where x represents what? What? Number of months. Very good. Number of months. And y is what? What's y? What's what? The weight, right? There we go. So in the other equation, this is changing. How do I get from here to here? What am I doing each time? How do I get from here to here? What could I multiply 50 by to get 60? Yes?
Same.
There's a track meet today, too?
Yeah, we have a chocolate.
Good luck. What do you do?
Chocolate.
I do
far?
javelin.
How much does it weigh?
5.5 pounds.
That's one. You don't get that. Okay. Go ahead, sir.
How much does a
Oh,
chocolate
so
weigh?
I think it's like
I have
20
to do a javelin.
isn't it? Wait, Sophie, you're going to give me the word. So. Javelin, you know, it's,
Yeah, I do a javelin.
I like the dangerous sports. I used to be a javelin catcher.
I have discus.
Yeah, discus is weigh approximately 2.5 pounds.
You see my muscles?
So-
I have a lot.
What? Okay, so to go from here to here, notice what I was really doing in that last, there's kind of an easier way. Y equals something, okay, so this is an exponential function, so we're going to start with 50, but what do I multiply 50 by to get 60? Not 0.2, I have to multiply by 1.2, okay? I'll show you, okay? Raised to the x power. Because it's changing, because if I multiply by 1.2, 5, because the 1 accounts for the 50, plus 0.2 accounts for the percentage growth, right? So I'm getting 50 times 1, plus, so this can be rewritten as, this is the same as saying 50 times 1 plus 0.2 raised to the x. Do you see it now? Okay? Because it's 50 times 1 plus 0.2 times 50, which gives you my new value. Okay? And so then I take that answer and I raise that answer to the next power of the next monthly power. So this is the number of months. Okay? Number of months, and again, this is the weight over here. Okay? This is the weight. And this one here is called, whoops, going back. The first one, where's the rest of the note? The type of growth of Fred's colt is called, if it makes a line, what's it called? It's called a linear growth. The type of growth Andy's colt is called exponential growth. And we've already talked about linear functions, so this unit is all about exponential functions. Anyone think of anything else that goes up exponentially? Like that penny problem that I started with, right? If here's the amount you have on the 30th day. If I start with 1 penny, right, and I multiply that by 2 raised to the x power, so this is my starting amount of pennies, and I'm multiplying, doubling it each time. So after 30 months, I'd have 1 times 2 to the 30th power. You understand? Hello? No? Right? If this was my penny problem, 1 times 2 to the x. So in general, you should write this down, okay? In general, where's my notes? I had my notes. I know where it is. It's on a PowerPoint, okay? So I'm moving on to this PowerPoint that I made. I made it, I stole it, where is it?
Those are the same thing.
What? Open your OneDrive folder, Advanced Algebra 1, Chapter 9. Exponential growth, and then, where did it go? Uh-oh. It's not here.
That's what you get for stealing things.
I know, 10:31 a.m. Shoot. I made this PowerPoint, but it's not there. I'll find it in a second. Exponential growth. Write that down, okay? Y equals a b to the x, where a is the starting value. So with my penny problem, we had y equals, we started with 1 penny. The growth factor was I was multiplying by 2 and raised to the x power. With the horse problem, he started with 50, right? I'm multiplying by 1.2 because it's going up by 20% raised to the x, okay? So b is like the growth factor, okay? How much am I multiplying that previous problem by each time? So moving on, let's see. So for instance, and we already talked about it. Do you need to write that down? We already did, okay? So go back.
Yeah, go back.
Go back. Okay. Right? So in both cases, this was my penny problem. You start with a penny, you double it every day for a month, right? This is, I start with a 50-pound colt. I'm multiplying by 1.2 each day, and this is how much it's going to weigh after X days. Okay? Moving on to the next thing. Okay, Jessica, can I move on? All right. So next, so pet frog. You guys can help me figure this out. My pet frog, here he is. Okay? I cut that for a minute. That's my pet. You guys have a pet frog?
Yeah.
You do? Do I? Okay. My pet frog had a starting weight of 10 ounces. He grew 10% each week. Who can tell me how to write this function? Okay? Go ahead, Quinn.
10 times 1.1.
Y equals 10 times 1 by 1 to the x power. You got it? Good. So you should probably write that down. You need to put your phone away. Jake, you need to put your phone away. Will, you need to put your phone away. Calvin, good. You know? Okay, give me your phone. The one that's in your lap, maybe? Yeah, that one. That one. Good. There you go. Okay? Give me your phone, Jake. You don't need it right now. Okay? Put your phone away. 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 We're not in phone class. Okay? Write it down. Okay. Next. Story. So we're going to write a story for this particular problem. Who could give me a story that goes with this problem? Who wants to be creative?
David.
Give me a nice point, a valuable point. Give me a story that works. Go ahead, Paul.
Microsoft Corporation has a starting budget of $25.
$25.
Yeah, they started really low.
Okay. So Microsoft started with $25.
You looked it up.
Okay. Michael, sorry. Microsoft, sorry. Microsoft started with what? $25. And
They grew by 30% each year.
grew by 30% each year. Okay? That might or might not work. What's going on over here?
I dropped my phone.
Okay. So yeah, that could be it. Very good, Cole. So that, I mean, it reminds me of an interesting story. My friend, he worked for Microsoft, and he told me did I tell this story?
No.
My friend, he worked for Microsoft, and way back when we were in college, he just graduated from C with a 4-year college degree, and he went to work with a computer science degree. He went to work for Microsoft in the 80s.
Wow.
And that's when they were first started. You'll say wow in a second. You quit being a wise guy, okay? But so he came to my wedding 20 years ago, and everyone who started there, like in the 80s, they got really good stock options, and those stock options went up exponentially, like they would double or triple or quadruple. When he came to my wedding 20 years ago, I said, "Hey Larry, how much money do you have in Microsoft?" And he said at that time, which was 20 years ago, he had $83 million in stock from Microsoft. That's the power of exponential growth, because he probably is only getting a few $1,000s each, but now he lives in Rancho Santa Fe, which is near San Diego, near Carmel and all that kind of stuff, and he has like this fancy, I went to stay at his house, which is like gates that open like this. We stayed in the guest wing when we stayed at his house. It was pretty cool. But now he probably has like hundreds of millions.
Did he give you any money?
Sorry, no, he's cheap. Go ahead. Yes.
Well, he has 83 million.
What?
So say like decline by 30%.
We're going to talk about that next time. Okay?
Say like wouldn't it cancel out something?
Well, yeah, but we'll talk about that. But declining, if it's declining, right, you're multiplying by a number less than 1, so it's going down. All right, so it'd be like.
But like if it was negative times it wouldn't just cancel out. So sometimes it might cancel out.
Yeah, I mean, usually things like if you look at stock prices and stuff or housing prices, sometimes the housing prices go up and sometimes they go down. But if you follow a curve, it might fit well to an exponential model. Especially like if you look at housing prices in our area, they have been following kind of that exponential growth model for a long time, so they're going up really well. Okay, anyway, let's move on. David, stop tapping. I purchased a baseball card for $25. The value of each increased by 3% each year. Who can give me an equation for that one? Calvin, can you?
What? No, I cannot.
Can you, David?
Do
Go
you
ahead.
have to make the function? Or just, the story's already made. Y equals 25 times the 3.
No, not quite.
Oh,
Go ahead, Mandy.
25
not 1.3. How do I take 0.03 raised to the x? Okay. So if it's going up by 3% a year, you add 0.03. So it's 1 point. Yes, Ian. Sure.
Oh,
Okay.
I understand.
So you get it. All right. So what's next on here? Okay. So population 100 lizards is introducing a new population, doubled every year, so those lizards, kind of like my penny problem, is going to go up very fast. That's kind of the end of the problems, okay? So now I have a worksheet for you that you can do.